All right, welcome everyone. If you're a senior dev or an engineering lead, you already know that AI coding assistants are just fundamentally changing how we write software. It's a massive, super exciting shift. But to move past that basic autocomplete phase and truly master GitHub Copilot at an enterprise scale, well, that requires a strategic pivot. So in this explainer, we're skipping the basics. We're going to dive deep into the source data on Copilot's security footprint. We'll master the foundations of precision prompt engineering, and finally, look at exactly how to scale these capabilities system-wide using Copilot CLI and GitHub Actions. Let's get into it.
So this is really the million-dollar question, right? It's literally the core concern of every technical architect and security officer out there. Because sure, we all love the massive productivity boost that large language models give us, but what are the inherent security risks of actually deploying LLM-generated code into production? When you look at the source data, the reality becomes super clear. We can't just blindly trust the output. We absolutely have to verify it. To put some hard numbers to it, a recent highly targeted replication study focused on Python code generated by Copilot revealed a very specific reality: 27.25%. The researchers tested the model against MITRE's top 25 most dangerous software weaknesses. And, the reason MITRE's top 25 is the absolute gold standard for this kind of test is because these are the most exploitable, high-impact vulnerabilities that are actually seen in the wild. They found that while Copilot is for sure improving, 27.25% of the generated suggestions still contain vulnerabilities. This proves that relying purely on the AI's default output just isn't going to cut it. Objective, rigorous security measures are completely mandatory.
So here is our roadmap for this explainer. First, assessing Copilot code security. Second, precision prompt engineering foundations. And third, Copilot CLI and automations. Section 1. Assessing Copilot code security. Looking at the data, there's a pretty fascinating trend regarding how Copilot security has actually evolved over time. Researchers focused on 12 distinct common weakness enumerations, or CWEs, from that MITRE top 25 list. And the data objectively shows progress. Older versions of Copilot produced vulnerable code 36.54% of the time, while the newer versions dropped that rate down to 27.25%. Now, an almost 10% drop is definitely impressive, but let's be real here. 27% is still a glaring red flag for any CISO. The trend line is absolutely heading in the right direction, but active mitigation on your end remains a hard requirement. When we look at this CodeQL output highlighting a CWE79 vulnerability, which is a reflected cross-site scripting bug in Python code generated by Copilot, it's pretty revealing. CodeQL is a static security analysis framework, and it's super interesting to see how it operates here. It actually finds these flaws by literally tracing untrusted user input all the way directly to the web page output, identifying exactly where the data gets executed without any sanitization. The researchers ran automated scripts to build databases and run these precise analyses, and it took just over 16 minutes in real time. Automated static analysis like this, that is your first critical line of defense. But, automation can't catch absolutely everything. For the really complex vulnerabilities that CodeQL just couldn't automatically process, things like CWE434, which is unrestricted file upload, or CW200, exposure of sensitive information, expert human analysis was still totally required. The researchers had 2 independent experts manually review 141 code samples. By focusing strictly on the specific targeted CWEs, they achieved a highly reliable 90% agreement rate. For your teams, the takeaway is simple. There is no automated silver bullet. Your security posture absolutely must interlock automated static analysis tightly with expert human review.
Section 2. Precision Prompt Engineering Foundations.
Knowing those risks, we kind of need to completely redefine what prompt engineering means for a senior developer inside the IDE. You might be super used to prompt engineering in a standard chat interface, but in the IDE context, your comments and doc strings are your prompts. It's a total paradigm shift. You have to stop thinking of comments merely as, documentation for the next developer, and really start framing them as a direct control mechanism for the LLM. You are actively steering the AI with natural language to prevent vulnerabilities before they're even generated.
So to actually get the best out of Copilot, you really need a specific playbook. First up, write descriptive doc strings in plain English. Second, set strict constraints. If an input can be null, tell Copilot immediately. Third, dictate the approach. Like if you want a binary search, explicitly say use binary search. And finally, provide sample inputs and outputs. Remember, Copilot is essentially a prediction engine, right? If your prompt is vague, it guesses. And I'm sure we've all seen the AI hallucinate a completely irrelevant library or some bizarre logic when it guesses wrong.
Specific constraints and examples are what lock the model into reality.
Another absolutely foundational best practice here is task chunking. And the technical justification for this comes directly down to the model's context window. Copilot is incredibly powerful, but if you feed it a massive, sprawling architectural request all at once, you just overwhelm the LLM's attention mechanism. It literally loses track of the instructions. The context window gets muddied, which leads to dropped logic, or worse, insecure shortcuts. The smartest way to use this tool is to break complex tasks into bite-sized, well-defined problems and just tackle them one by one. This maintains the context window's focus and dramatically increases both the security and precision of your output.
Which brings us to Section 3, Copilot CLI and Automations. Because Copilot isn't just an IDE plugin anymore, guys. It actually has a super robust CLI workflow. You can start right in your terminal by running /plan. From there, you can use /fleet to execute tasks across parallel subagents using different models. Then you just seamlessly transition into your IDE to refine the code, and finally, ship the pull request. What makes this workflow incredibly powerful is Copilot's native MCP, or Model Context Protocol support. MCP is the engine that allows the AI to securely index and retrieve specific repository state and issue context without you having to do all that massive manual copy-pasting. You literally move from the backlog to implementation flawlessly.
And it's really fascinating to see that we can actually take this a step further by bringing it directly into our CI/CD pipelines. Copilot CLI runs on a GitHub Actions runner, just like any other standard CLI tool. This means you can run it programmatically to automate those tedious, non-coding chores that just eat up your day. Need automated pull request reviews? Want to generate detailed release notes based purely on commit diffs? You can actually script the Copilot CLI directly into your Actions workflows to handle all of this automatically. Talk about saving your senior engineers hours of administrative work.
But, and this is a big but, when you're automating AI at this kind of scale, governance is literally everything. The recommended enterprise standard for pipeline automation is using GitHub agentic workflows. Rather than just dropping the raw CLI into your workflow steps, agentic workflows are designed specifically for automated environments. They utilize secure GitHub token authentication by default and come packed with built-in guardrails. This ensures your automated AI agents are operating safely and, most importantly, securely within your company's predefined boundaries.
So, that brings us to the ultimate question for you and your engineering teams. You've seen the research data on the vulnerabilities. You know exactly how to lock down precision in the IDE using context windows, and you can see the scaling power of the CLI using the Model Context Protocol. But are your pipelines actually ready to give AI the keys securely? Take a hard look at your architecture this week. Thanks so much for joining me for this explainer.